Burning fossil fuels, such as coal, is one of the most cost-effective ways to produce electricity and is almost as easy as boiling water. However, coal emissions contribute to global and local air pollution. A study published in November 2023 in the journal Science linked coal pollution to the deaths of almost 500,000 Medicare recipients between 1999 and 2020. In this video, we will examine, where does our power come from? How does burning fossil fuels generate electricity? And how do emissions affect human health? As we explore this week's Ethical Dilemma in Science, are fossil fuel emissions an example of environmental racism? We need energy to power our machines. We need energy for transportation. We even need energy for our smartphones. So where does our energy come from? Wind has been used as a power source for millennia. Boats powered by wind moved along the Nile River as early as 5000 BC. Simple wind-powered water pumps were used in China around 200 BC, and woven reed windmills, like in the slide here, were used to grind grain in ancient Persia by about 640 CE. Modern windmills turn turbines to generate electricity. In 2022, wind energy produced 907 gigawatts of electricity worldwide, and it is expected to double by the end of the decade. Electricity generated by wind energy in the United States has grown from approximately 1% in 1990 to 10.2% in 2022. Similar to wind energy, humans have used water power for thousands of years, from the Greek water wheels that ground wheat into flour, and the Archimedes screw for pumping water for irrigation from about the 3rd century BC. Today, we use running water to generate electricity rather than to grind grains, and it accounts for about 6.2% of the total U.S. electricity generation. Fire is another source of energy that was used throughout history for cooking. The energy in fire can also be used to separate metals from crude rock ores. Steam power is produced by combining fire and water. The first steam-powered vehicle was invented in 1769 and had a top speed of 2 miles per hour. Scottish engineer James Watt modified this first engine to create a more efficient, piston-driven engine that was ultimately used to power steamboats and steam railroad locomotive engines. It was also used to power much of the early Industrial Revolution. Since that time, steam-powered cars and airplanes have seen limited use, but a steam-powered car achieved a top speed of 148 miles per hour in 2009. The design of the steam engine was modified further in order to be able to use the energy in steam to produce electricity. And that's what's illustrated on this diagram. And so we've got a boiler here, which is basically a burner. We're going to put something to burn in here. So in this case, we've got coal, but it could be other types of fossil fuels, such as natural gas or petroleum products. As those products are burned, they're going to generate heat. That heat is going to convert water into steam, and then that steam energy is going to flow through a series of pipes and is going to cause this turbine to spin. And so as that turbine spins, it's going to cause the generator to spin, and that generator is what produces the electricity. And so we've got the electricity going out along the power lines. Now, within the power plant, what's going to happen is that steam energy is going to be cooled down, and so it's going to condense into water. That water can go into a cooling tower over here, and it's going to return through this condenser as, basically colder water, which will cycle back through and be converted into steam over again. And so it's a process that recycles the water in the production of steam to generate electricity. The cooling water will often come from some type of reservoir, like a lake or a river or some other source of water to cool the steam back into water. This image illustrates the change in our energy sources throughout history. And so what we can see, focusing in on basically the Industrial Revolution forward, prior to the Industrial Revolution and maintaining still traditional biomass, so like burning of wood or burning of grasses, remains a relatively stable form of energy in a large region of the world. But with the Industrial Revolution, there was a need for more energy. There was a need for more kind of focused, dense forms of energy. And so we can see that coal kind of started out as a replacement or an addition to the traditional biomass. And over time, we've seen that that has expanded into the use of other types of fossil fuels, such as oil here in orange or natural gases here in the blue. And so what we can see is that these fossil fuel plants have been used for generating electricity during an extended period of time over the last 150 to 200 years. Fossil fuel plants that burn coal and natural gas to heat water into steam produce over 60% of the electricity generated in the United States, as well as the majority of the electricity generated in the world. So the question is, what are fossil fuels and where do they come from? So the first example of a fossil fuel is going to be coal. Coal is an example of a sedimentary rock that is formed when remains of plants from a swampy forest were covered by dirt and rock, and as opposed to just simply rotting away, they were compressed over millions of years, and the heat and pressure converted that plant material into coal. And the different types of coal are produced by different amounts of pressure and different amounts of heat. Petroleum, oil, and natural gas are produced in a very similar way. In this case, the remains of microscopic plants and marine animals were again covered up before they could rot away. They were covered by silt and sand. And again, in this case, heat and pressure, again, over millions of years, converted these organic materials into oil and natural gas. Now, not all forms of energy are equal. Fossil fuels such as coal, gasoline, and natural gas are preferred as an energy source since they are energy dense. There's much more energy in these materials by weight than something like wood. Despite the benefits of using fossil fuels as an energy source, there are some problems associated with it. There are some hazards associated with it. Burning fossil fuels for energy accounted for almost 75% of total greenhouse gas emissions in the United States in 2021, and over 90% of the man-made carbon dioxide emissions during that same time period. Instead of revisiting the arguments about carbon dioxide and greenhouse gases and its effect on climate change, we're going to focus on other pollutants that are found in the emissions from these fossil fuels. In addition to the carbon dioxide that is emitted by burning fossil fuels, there are a variety of other principal emissions that are found in coal smoke. These include sulfur dioxide, the SO2 on this diagram. Sulfur dioxide contributes to acid rain and respiratory illnesses. The nitrogen oxide, the NOx, over here can contribute to smog and respiratory diseases. Particulate matters, which aren't shown on this slide, but basically kind of fine dust and particulates that are produced by burning of fossil fuels can contribute to smog, to haze, as well as respiratory illnesses and lung disease of those individuals that are downstream or downwind of these fossil fuel plants. In addition to that, there are things like mercury and other heavy metals that have been linked to both neurological and developmental damage in humans and other animals. In addition to these things that go up in coal smoke, there's ash, both fly ash and bottom ash, which are the residues created by burning these fossil fuels, especially coal, which are usually stored on site, but those materials can leach harmful chemicals into the surrounding waterways. Some modern power plants have emission control processes that remove some of the air pollutants from the flue gas, the gas that's produced by the burning of these fossil fuels. Now, these emission control processes act very similar to the catalytic converter in your car. Your catalytic converter converts toxic gases and pollutants into less harmful products. And so these devices, when they're used in power plants, can reduce the sulfur dioxide. They can reduce the nitrogen oxide. And they can hopefully pull out much of that particulate matter that contributes to very detrimental health and environmental effects, including respiratory problems. Now, an example of the effect of these emissions is acid rain. Acid rain is formed by sulfur dioxide and nitrogen oxides mixing with water to form sulfuric acid and nitric acid. But this is reduced significantly during the last 30 years as we've been able to implement these emission control processes. The problem is that these emission control processes don't remove all of the contaminants, and not all plants have these in place. As I hinted on that previous slide, government regulations such as the 1990 Clean Air Act amendments have resulted in significant reductions of the harmful emissions during this time period. In this case, from 1995 to 2022. And so we can see a reduction in nitric oxide. We can see a reduction in sulfur dioxide. So those harmful agents that are found within the coal dust and the coal smoke that's coming off of these fossil fuel plants. And we're seeing this reduction even though electricity generation has increased by 12% over this period of time. A study completed by the NAACP in 2012 looked at coal-fired plants in the United States and showed that millions of people live within 3 miles of these plants, and they have an average per capita income of about $18,400 per year. And again, this is 2012, so about 10 years ago. And we're predominantly people of color, 39% people of color. Now, studies have shown dramatic health effects downwind from these fossil plants. An example is a 2022 study that showed that there was a much higher likelihood of low birth weight downwind of these plants than there was upwind. Additional studies led by the EPA have shown increases in non-fatal heart attacks, increases in hospital and emergency room visits, acute bronchitis, asthma attacks, and lost workdays and school absences in the areas that are downwind of these fossil fuel plants. A shift in energy production away from the use of fossil fuels is complicated. Fossil fuels are the biggest source of CO2 emissions, carbon dioxide emissions, but they are also the biggest source of electricity generation. The use of sustainable green energy alternatives continues to grow, but energy demand is growing as well. Closing existing fossil fuel electric generation plants is challenging. There is a significant cost and time involved with building renewable energy sources, so there is pressure to maintain the status quo by using fossil fuel sources that have already been paid for, especially when fossil fuel costs remain inexpensive and plentiful. This is of special concern in developing countries that are looking for cheap energy sources to meet their own growing demands. Fossil fuel suppliers are even expanding extraction as new technologies such as fracking continue to serve as a cheap source of energy. Now, government policies and initiatives are difficult to implement as political polarization slows, and in many cases blocks progress. This is an issue that is further exacerbated when the debate often focuses on whether or not climate change is a real problem rather than looking into potential solutions. So this leads us to our ethical dilemma in science for this week. Are fossil fuel emissions an example of environmental racism? In order to answer this question, we need to consider, is it ethical to continue using fossil fuels when we know they contribute to climate change and health issues? Do the economic benefits of fossil fuels outweigh the environmental and health costs? And finally, how do we address the ethical implications of unequal distribution of environmental burdens in energy production? Thank you for viewing this week's Ethical Dilemma in Science. Please see the description below for additional information and references. You can leave a comment below with your thoughts on this topic or suggestions for future topics. If you enjoyed this video, please like it and subscribe for more discussions on the ethics and impact of science on society. Until next time, stay curious and be informed.